200 million miles from home, a spacecraft the size of a large van reached out and touched an asteroid for exactly 6 seconds. That was long enough. In that moment, NASA collected the largest sample of extraterrestrial material brought to Earth since the Apollo moon landings. This is the story of OSIRIS-REx. Its purpose was never just to visit an asteroid. It was to answer 3 questions humanity has been asking for a very long time. Where did the water in our oceans come from? Where did the building blocks of life come from? And could a rock like this one ever fall on us? Somewhere in the solar system, scientists reasoned there had to be a witness, a body old enough and undisturbed enough to still remember the answer. They found one, drifting quietly between the orbits of Earth and Mars. Before it had a name, it was just a string of characters. 1999 RQ-36. Discovered on September 11, 1999, by a near-Earth object survey working out of New Mexico, it was catalogued, tracked, and mostly forgotten. Just one more small body in a very large sky. It stayed that way for over a decade. Then, in 2012, with a mission already being built to visit it, NASA and the Planetary Society did something unusual. They asked children to name it. More than 8,000 students from 25 countries sent in entries. The winning one came from a 9-year-old third grader in North Carolina named Michael Puzio. He proposed Bennu, an Egyptian mythological bird sacred to the god Osiris himself, associated with the sun, with creation, with rebirth. Michael noticed something the judges couldn't unsee. The spacecraft's open solar panels looked like wings. Its sampling arm, unfolded, curved like a heron's neck, reaching down to the water. Even the asteroid's shape, a little like an egg. The name fit so well, it became official. But Bennu wasn't chosen for its story. It was chosen because of what it actually is. A B-type asteroid, dark, primitive, and rich in carbon, largely unchanged since the solar system's very first few million years. Half a kilometer wide, close enough to reach and return from within a single mission, and uncomfortably a near-Earth object with a small but real chance of colliding with our planet in the next few centuries. Which meant that studying Bennu wasn't just about the past. It was about understanding a neighbor. To actually reach Bennu and touch it, engineers at Lockheed Martin had to design something that had never quite existed before. The spacecraft weighed about 2,000 kilograms fully fueled, roughly the size of a large van built around a central fuel tank and a boxy aluminum frame. Its solar panels could fold back on themselves out of the way so they wouldn't be damaged by debris kicked up during sampling. 5 science instruments were packed onto its frame. 3 cameras, called arcams, to map Bennu in detail and to watch the sampling event unfold in real time. A visible and infrared spectrometer to read the chemical fingerprints hiding in sunlight reflected off the surface. A thermal emission spectrometer to measure heat radiating from the rock, and a laser altimeter contributed by the Canadian Space Agency to map the terrain in 3 dimensions, boulder by boulder. And at the end of a 3-meter robotic arm, the strangest instrument of all, TAGSAM, a sampling head that would never actually land. It would simply reach down, touch the surface for a few seconds, and fire a burst of nitrogen gas straight into the regolith. Like a reverse vacuum cleaner, reaching down from space to catch what blows upward. Nothing about this design was arbitrary. Every gram, every joint was built around one unforgiving requirement. It had to work perfectly the first time, with no way to practice on the real thing beforehand. The idea itself was older than the spacecraft. It started in 2004 in a bar in Tucson, Arizona, where a scientist and an engineer sketched out a sample return concept on a napkin. Their first pitch to NASA was rejected. They went back, redesigned it, resubmitted it to NASA New Frontiers program, and in 2011 they won. What followed was 7 years of engineering discipline. A preliminary design review in 2013, a critical design review in 2014, then 2 more years spent actually building and testing the hardware, piece by piece. The plan itself was almost absurdly ambitious for a mission budgeted around $800 million. Launch, chase an asteroid for 2 years, spend 2 more years mapping it in more detail than any small body in history, touch it for a few seconds without ever landing, fly 2.5 years back to Earth, and land a capsule of dust in the middle of a Utah desert, precisely on the very first try. There was no rehearsal for the real thing. There couldn't be. Bennu was 200 million miles away, and the mission would only get one chance to get it right. September 8, 2016, Cape Canaveral. An Atlas V rocket lit up the Florida sky at 7:05 in the evening, carrying OSIRIS-REx away from Earth for good. It was the 65th flight of the Atlas V, routine by the standards of the rocket itself. But for the team who had spent 12 years getting to this exact moment, it was anything but routine. It was the start of a 7-year round trip they wouldn't see finished until nearly a decade later. Somewhere on that launch pad was a piece of every one of those 12 years. OSIRIS-REx spent its first year simply orbiting the sun, waiting, gaining almost nothing but patience. Then, on September 22, 2017, it swung back past its own home planet, using Earth's gravity like a slingshot, bending its path just enough to match Bennu's orbit. Aim wrong here, even slightly, and there's no second launch to fix it. By August of 2018, Bennu was finally close enough to resolve as more than a single point of light. The spacecraft crept closer for months, firing its thrusters again and again, matching the asteroid's drifting orbit almost exactly, meter by meter. On December 3, 2018, it arrived, and Bennu instantly became the smallest object any spacecraft had ever orbited. Up close, the smooth little world astronomers had studied from Earth-based telescopes turned out to be something else entirely. A rubble-pile, armored in boulders, tumbling gently through the dark, exactly as it had for billions of years before anyone was watching. What followed was over a year of mapping, the most detailed survey ever performed of a small solar system body. And it revealed a problem. Engineers had designed TAGSIM assuming Bennu would offer wide, soft, forgiving ground, the way mission planners had hoped and modeled for years. Instead, they found a surface armored almost everywhere in boulders the size of buildings. There was technically nowhere safe to land, because there was nowhere safe, full stop. Out of the entire asteroid, the team eventually found one site that might work. Barely 16 meters across, tucked inside a small crater they nicknamed Nightingale. ringed by rocks large enough to destroy the spacecraft on contact if the approach drifted even a little. October 20th, 2020, OSIRIS-REx began its final descent, a slow 4-hour fall from orbit entirely on autopilot because a radio signal took 18 minutes just to reach Earth. There was no time for human reflexes. By the time mission control saw what was happening, it would already be over. The sampling head touched down, crushing a fragile rock beneath it on contact. 1 second later, it fired a burst of nitrogen gas straight into the surface, and Bennu's own regolith sprayed upward into the collection chamber. Total contact time, about 6 seconds. It worked so well that debris jammed the sample door open, and the team had to stow the sample early, just to keep from losing any of it back into space. Engineers still needed to know exactly how much material they'd captured, so the spacecraft performed a slow spin, weighing the sample using nothing but its own inertia from 200 million miles away. The answer, far more than the 60-gram minimum, the mission needed to call itself a success. On May 10th, 2021, OSIRIS-REx fired its engines and left Bennu behind for good, beginning a 2.5-year fall back toward Earth. September 24th, 2023. 4 hours before landing, the spacecraft released its sample capsule on a precise, unpowered path toward the ground, then quietly diverted itself away, never intending to follow it down. The capsule slammed into the atmosphere at over 27,000 miles an hour, glowing white hot, 82 miles above the Utah desert. A parachute failed to open exactly on schedule. A wiring documentation error, it would later turn out, but the main chute opened anyway. At 8:52 in the morning, local time, it settled onto the sand at 11 miles an hour, undamaged. Recovery teams, waiting nearby in helicopters, reached it within minutes. 7 years after launch, the sample was finally home. Inside Johnson Space Center, scientists opened the canister to find over 120 grams of rock and dust, nearly double the target, the largest asteroid sample ever returned to Earth. To study it, researchers brewed what they nicknamed Bennu tea, boiling fragments in water and acid to pull the organic compounds out for analysis. What came out of that tea reads like a recipe for life. 33 amino acids, including 14 of the 20 that Earth's own biology uses to build proteins, plus 1 tryptophan, never confirmed in space material before. All 5 of the nucleobases that spell out DNA and RNA, abundant ammonia, and scattered through the rock, minerals like halite and trona, salts that only form as ancient brine evaporates. Evidence that Bennu's parent body once held pockets of liquid water billions of years ago. One mystery remains open, though. On Earth, life almost exclusively builds left-handed amino acids. Bennu's sample contains an even mix of both left and right. Nobody can fully explain why yet, which might be the most exciting sentence in this entire story. Dropping off the capsule wasn't the end of the spacecraft. 20 minutes after release, still healthy, still carrying a quarter of its fuel, it fired its engines again. Renamed OSIRIS-Apex, it's now chasing a second asteroid, Apophis, a 340-meter chunk of rock that will pass within 20,000 miles of Earth on April 13, 2029, closer than some satellites. In September 2025, OSIRIS-REx used Earth's own gravity for one more slingshot, setting up its final approach. When it reaches Apophis in 2029, it plans something no mission has attempted before, dropping to within a few meters of the surface and firing its thrusters straight down, deliberately excavating the asteroid, to see what a close brush with Earth actually does to a body like this. It isn't just science anymore. It's a rehearsal for the day we might actually need to deflect one. So step back for a moment and look at what this mission actually achieved. It launched in 2016, reached an asteroid in 2018, and touched its surface for 6 seconds in 2020 without ever landing. It brought 121 grams of that asteroid home in 2023, the largest sample returned from space since Apollo. Inside it, scientists found the amino acids, the nucleobases, and the salty mineral history of a wet, organic-rich world older than Earth itself. And the same spacecraft, still flying, is now on its way to a second asteroid to help us understand how to protect this planet from the next one. That is 7 years, 4 billion miles, and 6 seconds on the surface of a rubble-pile, rewriting what we know about where we and everything alive on this planet actually came from. NASA has kept 3/4 of the Bennu material untouched, in reserve at Johnson Space Center, for scientists who haven't been born yet, asking questions we haven't thought to ask. A 9-year-old boy once looked at a spacecraft and saw a bird from 4,000 years of Egyptian mythology reaching down to touch the water. He wasn't wrong. Bennu survived the solar system's most violent years. Now a piece of it is home.